Let's try it again. Good afternoon. All right. Welcome to the Busy Developer's Guide to Virtualization. My name is Brian Randall. I'm a senior consultant with MCW Technologies. And this session is focused on how you can get the most out of the Microsoft virtualization stack, specifically Hyper-V on Windows 8 and Windows Server 2012. I will not be discussing lots of the server features. I'm focused primarily on what you would get out of this as an individual developer, which also means I'm not going to cover things like team build, lab integration, how you would do it there. I'm going to show you that virtualization for you is a great thing just when you're doing basic developer things. I'm also not going to talk about other competing products. Now, it has nothing to do with lack of understanding or even Microsoft saying you can't talk about, oh God, VMware, oh, scary. No, it's simply that I have enough to talk about in 1 hour and 15 minutes with all the great stuff that's in Hyper-V, that if you want to know about VMware, go to VMware Conference, or if you want to talk about it, I'll be here the rest of the week. Okay? So I've got plenty of stuff to talk about. And when we think about how this fits as a developer, it's these changes we're having as we do development. The first thing is that we've seen this large growth in the demand for our services. I think we're very lucky as IT professionals today because I'm busy as all sin. I see you guys in the audience, which tells me that, well, guess what? Most of you are probably here because your company paid for you to come. Now, if any of you are paying your own budget, you're hardcore and see me and I'll buy you a beer. But seriously, the fact that companies are sending you to a technical conference to learn is a sign of health for our industry. And we're growing. We are in high demand. There's also this need for innovation. Innovation means often building multiple types of solutions for multiple platforms, right? And when we think about doing that, the complexity of the environments we need to build is ever growing. And so those are things we need. The other thing is the complexity of doing team development, how you have to interact with other people. When you're working on a newer build, a newer branch, a new section of code, and someone wants you to look at code from another previous build, or even a previous version, maybe a version that only runs on a previous operating system that maybe you've dropped support for. And then finally, we think about the cloud, this idea that we want to be able to move infrastructure out of our data center and up into the cloud. And virtualization has shown a huge benefit in that world. But for me, the number one thing I love about virtualization is the following. So let's switch over here to one of my dev machines. And we'll wait for the projector. And let's see if I picked the right one. No, I'm challenged already with the projector. So we'll try this again. Wait. And now he's happy. Yay! Pretty tulips. Okay. Actually, that's kind of funny. We're in the Netherlands. Tulips. That's just the Windows 8 default arrow wallpaper. So this is a virtual machine, and I've got some code here in Visual Studio 2010. The code's really not that interesting. It's going to run a program. Unfortunately, when I was playing with this earlier, I found a little problem. So let me show you. F5. Give it a second. Now, I don't know if you guys can see that, but look in the middle of the screen. It's the toilet bowl of death. Right? The little spinning circle. I'm being flushed away, and that's a bad thing. Now, I know what the problem is, and the best part is to go out of here, close the RDP connection, and let's go to the Hyper-V Manager. And let's find this VM that's running. Let's connect to it with the console. Oh, yeah. This is why I love virtualization, because I'm simply going to do this, turn it off, close this down, come down here to what are called snapshots, right-click and say Apply, Apply, and now my machine works. I don't have to worry about anything that's messed up in the data. I don't have to worry about corruption. I'm back to where I started. That right there for developers is why you should love virtualization. It covers your back end. It's looking out for you. And that's just one of the things. You guys are, I'm going to call you alpha geeks. No offense if you don't like being called a geek, but that's a compliment. Any of you like to run pre-release software? betas, alphas? Or how about you just like to run software that people are calling release software and it's actually pre-release, right? I mean, Google had Google Mail, Gmail in beta for 5 years, right? Well, I don't like putting beta software on my production machine, right? I want to keep it segregated. I want to keep it a place where if it does something nasty to my machine, I'm not going to break down. So those are the reasons why I think virtualization is super compelling. And I'll get it down. There we go. So, complex world full of technology. Virtualization is going to let us abstract a lot of that technology into reusable containers, reusable components that we can then plug into as places to do development, to do test, and even to do things as innocuous as surf the internet. Now, I'm not saying you would go to any dark, deep, scary places on the internet, but virtualization provides another mechanism to isolate you from the bad guys. I find virtualization is great for my children. They fire up a VM, and the problem is my 8-year-old, who will be 9 in August, is getting a lot smarter, right? And, you know, I've got the firewall, I've got stuff. I don't have it ratcheted down too tight, but now I'm getting to the point where I have to lock it down. But now I know at some point he's going to do something, because the kid's going to be smarter than his old man. He's going to think of something I didn't think about, and I'm going to come up and he's going to find something's wrong with his machine. Well, I don't have to worry about it. I just dump it, throw on the latest undo patch, and he's back to normal. It makes my life better in and outside of work. And provides that flexibility you don't get with standard hardware. In the old days, I used to carry a lot of spare hard drives for my laptops. The problem is, I love these new lighter and thinner laptops. They're getting better and better. And if you notice, for example, from vendors like Samsung and Apple, these really super thin ones, you can't swap out the hard drive, right? You're stuck with whatever is molded into the case. Virtualization says, you don't have to worry about that. You want to run Windows 7, Windows 8, Windows Server 2012, go for it, all at once. As long as you have the right hardware, you're good to go. So the first thing I'm going to talk about is what type of hardware should you have? What should you use? I'm going to talk about the software you need and what we're going to focus on in here. And then we're going to drill down in how you work with virtual machines and all the core settings. And what happens for a lot of people is just there's so many options. They're frustrated. Why do I care about this? What's the important setting? What do I need to know? Because I assume you're not in the data center. If you're an IT pro, you're in the wrong session, right? Go to Jeff Woolsey did a great session. Go watch his video. Go see the IT pro deploying for your network. This is for a single person who doesn't spend their time here, who spends their time mostly in Visual Studio. And then we'll look at optimizations, tips I've learned over the years, and things to help you get the most out of it. Now, a couple of vocabulary points. When we talk about a virtual machine, right, we're talking about an isolated guest operating system installation that's running on top of a normal host. So what's the host? The host is a physical host. I've got 2 physical computers here. These are host machines. And each one is going to be running 1 or more virtual machines that we generally refer to as a guest. Okay? There's additional terms all throughout, but these are the big things. So when I talk about host, you know I'm talking about the machine, and I'm controlling the runtime environment that's going to host my virtual machines. Now, there are many different types of virtualization. Operating system, which is what Hyper-V is focused on. There's also application virtualization, where you isolate one application from another on top of the operating system. Presentation virtualization. We've been doing this for years in various things like X Windows and things like RDP, right? VNC, where you're moving the virtualization stack from the physical computer via software to another execution context, typically another machine. And then we have even device virtualization, where a hardware device is presented to the operating system, whether guest or host, that appears to be a particular type, but it's actually emulated in software. So for Microsoft, the 2 big ones I'm going to talk about today is primarily Hyper-V and something they added in the Windows 7 Server 2008 release timeframe called Native Boot Virtual Hard Disk, or Boot to VHD. Native Boot Virtual Hard Disk is what you'll find officially the documentation name. That's what the folks at Microsoft call it. But if you do any searching and you want to get tips and tricks and stuff, search for Boot to VHD. That's what's going to help you find topics. Now, Hyper-V, operating system virtualization. Native Boot Virtual Hard Disk is device virtualization. All the other things at the bottom I'm not going to talk about. AppV, that's application virtualization. That's a server-side product from Microsoft. Remote Desktop Services adds enhancements to the RDP protocol and the RDP services, formerly known as terminal services. And the Virtual PC, Virtual Server, and Windows Virtual PC are all predecessors to Hyper-V, but they're a different type of virtualization stack. They're known as a host-based virtualization stack in that they run in user mode. Hyper-V, on the other hand, as we'll see, is a hypervisor virtualization stack, which means it runs as a very thin layer on top of the hardware. And even the Windows GUI that you're going to see later is actually somewhat virtualized. It is considered what's called the parent partition. And it's a special virtual machine, whereas every other guest is running in a guest partition. Okay? And the key thing, the difference there is that in the parent partition, that is where you load hardware-specific drivers for the host. All the guest virtual machines will use virtualized or emulated drivers inside. Now, Hyper-V is available as a role for 64-bit versions of the appropriate Windows operating system. First was Windows Server 2008. Then they added updates in 2008 R2 and 2008 R2 SP1. And in Windows Server 2012, this is their big third release, right? And if you've been doing the Microsoft world of software for a while, you know they get a lot of things right often in that third release, right? Anybody do 16-bit Windows 3.0? Pain and suffering, baby. Woo! Okay? Right? Look at when they went to Windows 95, then Windows 2000, and then we had NT. It gets kind of blurry there because they had two code lines going. Right? We start thinking about, though, NT3, 351, NT4 was a really solid release. Okay? So they've really done a lot. And if you went to the keynote on Tuesday, Jeff Woolsey showed an amazing set of features related to Hyper-V. And this best part is, for developers, you're going to probably do it on Windows 8. Because starting with Windows 8, we now have Hyper-V on a client operating system. You notice those first three versions, right? Those are all server-based. With Windows 8, and this is available now for you to play with in the previews, you get a ton of the core server-grade features on your desktop. Okay? And some are pretty impressive. Things like dynamic memory, right, is built in on the client as well as the server. The other thing, though, is all the performance work they did to give you that demo where Jeff showed 1 million IOPS inside a virtual machine. I mean, that was insane. Right? We're going to look at IOPS in a second for a typical laptop. And when you compare the numbers I'm going to show you here with what Jeff showed, you just got to go, damn. Now, that said, Jeff also had to put a pretty big paycheck down. Right? They used something like 40 SSDs with 5 controllers and a bunch of, insane hardware. Right? But the fact that they can do that in a virtual machine is just money. Right? That's just great. Now, the key thing to understand about Windows 8 and Hyper-V is that it will be a feature that requires the professional version of Windows 8. Naturally, it only works on Intel-based versions, so no Windows 8 RT tablets are going to be running Hyper-V. But if you went to Build, last year, they gave us tablets that run Hyper-V. Basically, Core i3s, Core i5s really is what you want to have, and Core i7s are all good processors and equivalent AMD processors. Now, setting up your host is really straightforward. Put down the appropriate version of Windows, and you just use add. God, I always type remote. I've spell checked this 14 times, but of course that's spelled correct. It's remove programs on the client, and use Server Manager, add role. So let's just switch over here, and I'll show you where this is. In particular, on Windows 8 client, it's kind of hidden. 1, 2, 3. Look at me. There we go. Okay. So I've already got Hyper-V installed, of course, so I'm not going to reinstall. That'd probably be a boring demo. I just want to show you where it's at. So fire up the control panel. Come in here. Go to your Add Remove Programs, or also known now as Programs and Features. And you'll see right up here is Turn Windows Features On or Off. Okay? And in fact, I'm going to do one last thing. Sorry, I should have started that earlier. There we go. So turn Windows features on or off. You click that, give it a second, and what you want to do is come down here and alphabetically, there's Hyper-V, and let's do this over here so it doesn't pick up that tooltip. There we go. There's two pieces, the management tools, and that's the GUI I'm going to be showing you, as well as support for things like PowerShell, and then the Hyper-V platform. Now, the key thing to understand there is that it's possible that you can install the tools, but you might not be able to install Hyper-V, and I'll talk about why in a second. So all you need to do is those boxes will be unchecked on your machine. You check them, start it up, and away you go. Okay? Once it's installed, then you can create a VM and you're good to go. Now, on the server, oh, look at that. So this is Windows Server 2012. The way you do it there is you go to the Server Manager, and on the Server Manager, there's this option right in the middle of the screen, really nice and big, Add Roles and Features. You click Next, maybe you read it, maybe you don't. Next, Next. And you go down the list, and it's grayed out, but there's basically Hyper-V. You check it, Next, Next, go. Okay? Okay, in production server environments, you probably should read the dialog boxes, but if this is just a dev box playing around, don't worry about it. Okay, that's it. Once you've done that, you'll be able to start creating virtual machines and living the happy virtualization lifestyle. Now, here's the biggest problem people have with virtualization. They try and do it on crappy hardware. And I'm sorry. I'm sorry if your boss buys you crap PCs. And if he does, and you know it doesn't meet what I show you here, and you can't get him to get you something current or her, we'll pick on everybody, then just don't do it. Because you're just going to be unhappy, and you're going to say it all just sucks. Now, Microsoft had an uphill battle. So what happened was that people would try their stuff, and they'd compare it to VMware. They would try something and go, oh, well, VMware's better. The problem is often it was like they were trying some of the Microsoft stuff on a crappy laptop, and they were comparing it to VMware running on some server-grade hardware in their data center. Okay? Trust me, VMware on the desktop sucks just as bad as Hyper-V on the desktop on crappy hardware. I guarantee it. Okay? When you're using Hyper-V, you are virtualizing an operating system. You're creating a second machine. That doesn't come for free, folks. Your machine has 2 gig of RAM, and you're going to try and run the Windows 8 beta on your Windows XP machine? I'm sorry. Pain and suffering. Okay? Now, sadly, the scary part is if you have the right hardware, but only like a little RAM, you can actually get it done. Windows 8's amazing. We can get it down to 512 megs of RAM. That's pretty impressive. Okay? Now, you can't do much, but hey. So let's talk about these things. The first thing is processor. This is critical. Now, if you got a machine that you bought in the last year or two, you're probably good to go. Number one, you need Intel VT or AMD V. This is what's called hardware-assisted virtualization. And it's basically functionality that's built into your processor. Now, you might go in your BIOS and there's a bunch of other stuff. Well, I'm going to show you the BIOS screen for my laptop, which is fairly simple. Servers tend to have a few more options, and it might be a little different for AMD-based processors. But in general, there's only one thing you have to make sure is turned on that could be off. Because particularly if you've got a consumer laptop or if you've bought a consumer desktop, a lot of the vendors like Dell and HP turn the feature off. Now, in the old days, Dell, I'm talking to you, would actually sell you a machine that had the capabilities on the chip, but they turned it off in their BIOS. They locked it out. Why? I never got a straight answer. Anyone from Dell PR? Love to talk to you so I can quit bashing you. But until then, I was upset. I spent money on a nice PC, 4 gig of RAM, and this is a few years ago, but it was a good machine. And I couldn't run virtualization technology that needed this. Now, here's the big thing, though, for Windows 8. For Windows 8, you need to have what's called SLAT, Single Level Address Translation. AMD tends to call it, I think it's MPT or RVI. Intel calls it Extended Page Tables. The reason you need SLAT is simple. If you're running Windows 8, a majority of people are going to want to have a decent graphics card. Right? Any gamers in here? Right. So you probably got a nice ATR NVIDIA card, gobs of RAM, cores, it's smoking, right? You're playing. I don't play games because I can't play with my kids yet. My wife won't let me play the good games like, Gears of War and stuff. But the point is, you're going to run that stuff. You're going to want to put some hardware behind that, right? The problem is, it turns out that the way video cards talk to the device driver, they tend to clear out and do something called write combining, and they basically dump out information in the processor's memory cache. Well, what happens is whenever it does that a lot, and basically it's causing these page faults and causing the hypervisor to have to page stuff back and forth. So it really slows things down. In fact, if you want to see this in play, install, say, Windows Server 2008 on a machine with a good graphics card to enable Hyper-V. On my machine, when I press Control-Delete, it should be instantaneous, right? When I installed Hyper-V, because of this problem, and they didn't have SLAT on this machine I had, it would take 5 seconds for the screen to switch from desktop mode to the Control-Delete screen. 5 seconds. That's insane, right? It gets worse when you try and run something like watch a movie or play a video game. With SLAT, the processor mitigates that problem. And this is a problem that affects all hypervisors. Now, you wouldn't hear about this with ESX server because, oh, does anybody try and play Doom on their ESX server? Gears of War? No. So even ESX server would have the same problem, and Hyper-V originally was only for servers. So when they brought it to the client, they said, we know what the problem is, we can address it, we do some stuff in software, but you have to have SLAT, okay? Now, in your BIOS, what you're looking for specifically is Intel virtualization technology. It might have a little subtle name. Now, you notice hyper-threading is turned on. In modern processors based upon the I series from Intel, you want to leave it on, except for one condition I'll tell you later. And the other one is Intel VT-D. Intel VT-D does not do anything today for Hyper-V. Now, on my laptops, leaving it on doesn't do anything. In other words, Hyper-V works just fine. This is something that Microsoft will generally tell you, turn it off just to remove something from the equation that could cause you trouble, particularly on servers. But the only one you have to have on is that middle one. Okay? Now, the question is, how are you going to know if your machine will run this, right? Well, the best thing about this is, everybody's favorite Uber geek, Mark Rusanovich, technical fellow at Microsoft, has written a little systems utility called Core Info. Actually, it's right here. And there's lots of switches. It'll tell you lots of great stuff about your processor. But if you do Core Info-V, and you have to run this as an administrator if you have UAC on, and I didn't start the command prompt, so it tells me, forget it. Okay? So let's start it as administrator. I did that on purpose, really. All right, so let's go over here. Util. There's a bunch of stuff, but then if you do it again with the -V, what you'll see there is, first of all, it tells me what kind of processor I have. Okay? So this is a fairly current i7. This is just before Sandy Bridge, extreme processor. Now, I have the hypervisor turned on, and that's why we see this asterisk there. That's saying it's on. When it's on, they can't read these features correctly. The minus means they think it's off. Well, it's obviously on, and that's why there's kind of this top level bit. What will happen if you go to a machine that you haven't run it on that supports it, you'll get a dash and then 2 asterisks telling you yes, it's supported and that it has SLAT. That means you can put Windows 8 with client Hyper-V on your machine. Now, here's the thing. SLAT is only required today on Windows 8 client, but the server doesn't have to have it. So you can use server as a backup even if you don't support this. And actually, I have a really good Dell that I had that was just missed the SLAT features, but I can still run the server. Okay? There's some server features you can't use, but you can use all the core things that you would use VMs for development for primarily. Okay? So this affects primarily the client. The bottom line, though, is you really want a processor with SLAT. You'll just get better performance. Now, here's the question. Maybe you're going to buy some machines, and you're like, well, I can't go run this tool on them. Great. The good news is Intel specifically has said, well, we're not completely crazy now. We will now tell you if a processor has this feature. If you search for your processor, you'll get to a website, and the key is just look for the start. It should be ark.intel.com. If you go there, this will describe the processor and all the features. And what you want to do is come down and look for something that says extended page tables, EPT. And if you get a yes there, you know you're good to go. Now let me show you, this is for my processor, but what if about a new processor? Well, this is the good news. Ivy Bridge processors, which are the new series, or Sandy Bridge, all have EPT. So here's one of the current high-end Ivy Bridge processors. Scroll down, you're good to go. Okay? I haven't found the stuff on AMD's website. Hopefully they've updated theirs. It's a little harder with AMD, I've found, to find the info. But if it's been made in the last year, you're good to go. Like I said, just be careful with some vendors. If you're going to buy a lot of machines, say, look, if this doesn't work, we're going to string you up. Give us a loaner to try. Okay? Now, I've given you a lot of links already. Any links will be on my blog. Okay? And my blog address is right there, and I'll put this up at the end. And I got my email address at the end. On the slides, you can find it all. But all the things I'm showing you, I'll put links to. So core info, where to get it, how to find the Intel stuff. So you don't have to try and write all that stuff down. Okay, so let's go back to the slides. So we know my machine can run Hyper-V. That's pretty good news since I'm doing a talk on it. You really just don't like me when I press you that way. There you go. It wants me to push it harder. Okay. Now RAM, it's real simple. Generally more is better. Now that's two ways. Definitely as much as you can get in the box, party on. I've got 32 gigs in my laptops, so I can run a full-featured pseudo domain. I can do test environments. It's great. 8 gigs really is a good minimum to have today, especially if you're going to run Visual Studio, maybe Outlook. You're going to run your IM client, do a little surfing, maybe listen to some music coming off the net, right? And then you want to fire up a VM or two, right? 8 gig is really the minimum you should have if you're a good developer. 16 gig, party on. 32 or more, rock star. I mean, that's just great. And RAMs come down generally so cheap. It's great. Now, physical storage. I would argue, given the choice, buy faster disks and less RAM. And here's why. RAM comes down often so cheap as you get to later in the cycle, you can sneak that in usually really quick. Hard drives are harder to replace because you have to reinstall software, that's downtime and everything else. On most machines, especially a desktop, I can get new RAM in 15 minutes. Right? And I've done this at jobs before where I've seen guys, they will buy their own RAM because they just can't stand it. Okay? Bottom line is SSDs. Okay? But Brian, I've read these things, these hybrid drives are pretty cool. Yeah, okay, so there's hybrid drives. And if you're stuck with mechanical drives, then you want some with the fastest spin rate, spindle. Okay, you're going to see drives generally, your large external drives that you see at your favorite computer store, 2 terabyte drives, those are typically slower. They're about 5,400 RPMs. Most of the large areal density ones, the ones that do 2, 3, 4 terabytes, they're going to actually have a variable speed. Okay? 7,200 is really the minimum you want to go for. If you can afford it, get yourself some Velociraptors. Those are 10,000 RPMs. Or if you get workstation class machines, serially attached SCSI. But really we've hit that tipping point where SSDs have come down. I don't know how it is in Europe. I didn't look at pricing. But in the US now you can get like a 512 gig Crucial SSD, a really good SATA 3, 6 gig per second from Amazon for about... last one I got was $389. They had a little bit of a sale, normally about $400. Right, we're getting to the point where we're crossing that line where SSDs are not out of the question. And I'll give you some more links that you can even take to your boss, justify from other people why it's so important, just for regular developers. You can store your VMs on the network. This is a little more complicated. You can do iSCSI, which is pretty cheap. Definitely production SANs are good. Production SANs, one of the downsides for developers that I've run into is the company will get really hot on virtualization. And they'll say, we're going to put your workstation in a VM. And you're like, oh, please don't. Oh, no, it'll be great. And then what happens, there's some IT guy in the back who's controlling things and says, okay, I'll give them all. Oh, yeah, they only need, half a gig of RAM. They're just, developers. And the other thing they'll do is, SANs are often broken into what are called logical unit numbers, or LUNs. And what they'll do is they'll segment out some blocks of disk space. And they'll put 4 or 5 developers on one LUN. So you have lots of I/O contention. Okay? Yeah, it just sucks. I had a guy at a conference last month talk about it. And I would go, well, dude, they're abusing you. There's not much you can do. Right? On the other hand, you saw what Jeff did. Now, Jeff did direct attached storage, but they've also done demos where they've done it with SANs. You can get great performance out of SAN for VMs. Because that's what they do in the data center for production servers. So don't get screwed as a developer. Fight for your rights. Okay? Now, here's a cool thing in Hyper-V, if you want to use the new server for stuff. You can actually use SMB3, which is a new version of the network protocol in Windows that allows you to put your VMs on the file server and run them over gigabit Ethernet or faster. So this is good if you have, maybe you have an SSD that you keep local for one of your VMs, but you got some other ones you just need occasionally. Put them over there, run them across the wire. Good stuff. So performance, let me show you some numbers. Now, what I did was, before TechEd, I went and bought a brand new Seagate Momentous 750 gig laptop size hard drive, so 2.5-inch hard drive. I'm sorry, I don't know the millimeters, but laptop drive. And this is considered one of the really good, if not the best, hybrid laptop drives. Now, the key thing to look at is those IOPS, okay? Even at the fastest rate, they're only pushing 277 IOPS in this test. Now, this is a synthetic test, similar to what Jeff did. So remember, he got 1 million. I'm getting how much out of the laptop here? No, different class of hardware. Let me show you what I get with that Crucial drive I mentioned, right? And by the way, the Crucial drive is not considered top of the line. It's very good, but not top of the line. Look at the IOPS. Let's look at your 4 KB, which is often a block size on large drives. 63 versus 4,466. Do you think your VMs will start faster on that SSD? Yeah. Okay. The other thing that you don't see here, I did another test, and I'll post them on my blog just for kicks. These are random reads, very common. Okay, and random writes are very common. I also did sustained throughput, where you're trying to hammer the drive, so copying on and off. The Momentous had a declining graph. Okay, it's sustained throughput. Basically, once you blew through the cache, just deteriorated. You gotta have it. I'm sorry, it's probably the biggest thing. That's even more than RAM. Okay, video generally doesn't affect things. I've already talked about the issues with video. That's why we need SLAT in the processor. There is something, though, called Remote FX. Now, Remote FX is a server-side technology. And this is something I'm telling to you for one major reason. If you get stuck and your boss makes you move your development box into a VM on some server, and it's going to be Hyper-V, tell them, all right, if you do it, you got to give me Remote FX. And they'll go, huh? And what you'll do is you get this talk called VIR 313. It goes into great detail. Remote FX does a lot of things. But one of the things it does is you put a desktop class high-performance video card. Yes, a nice NVIDIA or ATI with lots of RAMs, lots of fast-smoking processors. You put multiples in fact. And what will happen is they will use that processor on the server to do a lot of graphics processing for you. So when you're RDPing in, you can run high-definition video in your VM. You can turn on Visual Studio. When Visual Studio says, am I running with DirectX? It says, yes, you are. And so Visual Studio, especially 2010 and 2012 that are WPF based, you get great performance. Okay? So this is for you guys. Once again, this is more of an IT pro feature to get implemented. You can do it on your laptops too, but this talk goes, it's a whole talk on it. And there's things like USB redirection and a bunch of other great stuff. Okay? So let's create a guest. Let's just go through how do we do this. All right? So let's come over here. And there's two real ways to do this. One is from scratch, which we'll do. You really don't like me. There we go. Okay. So, it's real simple. Start with the Hyper-V Manager. Where did I get that from? Well, on the start screen, it'll get pinned when you install. Okay? So I click that, fire it up. Now I've got a number of VMs already running, but we'll start up some more. And we'll say new virtual machine. You get the happy-go-lucky wizard. First thing is, what do you want to call it? Okay? The name you use here will be a part of the subdirectory where it's put. Okay? So we'll call this live AMS for Amsterdam. Now, where do you want to store it? Now, this is a silly, crazy, stupid thing. You think you want to put your VMs on your system drive? No. Now, granted, if you only have one drive, you don't have any choice, so yeah, good as anything else. Not a big fan of this, and definitely not a fan of the system drive if I have a choice. Okay? What I like to do is go to Windows Explorer, and I create a directory that is the root for my VMs. Now, because I do some other things we'll talk about in a minute related to multi-booting, I even put the drive letter that I think it is, right? And then if we go inside there, you'll see that I've got some folders with my VMs and all the various pieces that make them up. Okay? So you got to pick where you want to put it. So we'll go over to D, and that's good. Next. And by the way, in 2012 and in Windows 8, you can change that default location. How much memory? I don't know. 512 sounds good. Ooh, use dynamic memory? Absolutely, because I don't know what it is, but I'll click it. Next. Oh, do you want to be connected to a network? Well, sure, that's fun. Okay, well, I've got a hardwire, I've got something called Wi-Fi, and I've got internal. Let's go for hardwire. Party on. Now you need a hard drive. Okay? Virtual hard drives, I'll talk a bit more, but basically they'll create one for you. You can use an existing one, or you can attach it later. And we'll do attach later, because I'll tell you some more stuff. At this point, I'm done. When I hit finish, what it will have done is created an entry here for me. It'll be in an off state, so it's not using any CPU and no memory. Once I've done that, I'm going to go to settings, and I'm going to adjust a few more things before I try and install my operating system. Okay? I'm going to just go through really quick, and then I'm going to cover each of the major features in a little more detail. Okay. First thing is, what do you want the BIOS to do? Well, I want to boot from something. If you boot from CD, you can boot from your physical CD if you still have one, or what most of us do, we use an ISO file, right? Probably download from MSDN or TechNet. Okay? You can also do Pixie boot, which means you can boot up and create a machine via network installation. Okay? In that case, you would use legacy network adapter. Now, memory, you get a choice on that wizard. Lots more options here. Going to leave the default. But then you get processors. Once again, the default is 1. One's never enough, right? We need at least 2. Okay, so we'll change this to 2, and we'll talk about this in a little more detail also. IDE controller. So the hard drive thing is telling us, hey, where am I going to put my stuff? A hard drive in a VM is virtualized as a file or multiple files on the host. Okay? So I can say add, and then I can browse to an existing one. So for example, I could come over here to my machine and go to Hyper-V on G. I've got a VM here. And I could pick this one, for example. Okay? Add that. If I was going to pick an ISO file or point to my DVD drive, this is where I do it. Okay? And then here's my network adapter, lots of other stuff here. You could even boot off a virtual floppy disk. Don't know anybody who does that, but in theory you could. Then you can also add some description about what the VM is for. And then there's something related to services, which I'll talk about. At this point, we just need to be able to feed it some installation media, right? Either an ISO file or a physical media. Hyper-V supports a specific set of Microsoft and third-party operating systems in the typically Linux variations. I'm not going to provide the list, but it's most of the modern stuff you'd expect. But you will find that if you compare them to VMware, Microsoft has a smaller level of support. Here's the thing that I always just tell people. When you're looking at that list, first of all, do you really care that VMware says they support some esoteric operating system no one uses? If they do, great. But here's the thing when they say they support Microsoft operating systems or they do something. Well, Microsoft only supports certain modern operating systems. NT4, for example, they don't. Last time I checked, VMware was saying we still support it. Does anybody know if VMware has the NT4 source code and can make fixes to it? Anybody? I'll tell you the answer, they don't. Okay? That's an out-of-support operating system from the vendor, Microsoft. Okay? So if it doesn't work, VMware can't fix it unless they change VMware. And maybe that's the problem. They'll fix VMware. Great. You're good. If it turns out it won't work because it's NT code that needs to be changed, they can't fix it. So just be careful when you see the word support what that means for that operating system. So what Microsoft supports means it will use the current features, it will do these things that are available. A good example when you're checking for support is if you want a feature like dynamic memory that requires modern operating systems on the server side and requires higher editions on Windows, so the professional or enterprise editions. Okay? So keep that in mind when you're picking your OS. Once you've done that, you click OK, and I wasn't going to show installing Windows. It's not very exciting. Okay? There's a couple things I'll talk about, but you get it installed and you're good to go. There's more features though to talk about. So that's it. That's all I have to do and run the wizard. But you still don't like me, do you? I'm having to do a double push. There we go. So, supported guest operating system, go to the Microsoft website, map the version of Hyper-V to the operating system. And here's what's important. To give you a great experience, one of the things Microsoft does for supported operating systems is they provide what are called integration services. Integration services give you things like the ability to click on the console, click out, and have the mouse automatically move. Give you the ability to have what's called time synchronization. Virtual machines tend to have what's called time drift, where they, because they don't have a physical clock, right, they have to keep in sync with something. Integration services will do that for you. Of course, if you're using some kind of network synchronization to an NTP server or a domain controller, party on. You can choose. But integration services provides all those features. And supported operating systems have them. Now, the way you get integration services installed is one of two ways. The first way is you run an operating system that has them built in. Starting with Windows 7, Microsoft puts the current version of the integration services inside the operating system. So when I installed my Windows 8 VM on top of my Windows 8 Hyper-V, I didn't have to do anything because it's already there. However, for my Windows 7 machine, I had to upgrade them. Now, the way you're going to do that is you're going to mount a built-in ISO file that comes with Hyper-V. You're going to run a setup program, and once it's done, you'll get all the features. Time sync, the ability to have, is the computer alive? The other thing you get with integration services is that you can come to a virtual machine, and you can shut it down. Oh, I hit the same one. That was my fault. It wasn't the machines this time. I really should have blamed it, though. There we go. So you'll notice, for example, that I have a VM running here. Well, because I have integration services, I can right-click and tell it to shut down. Okay? I can also tell it to reset. Okay? And then it'll go through and do that through the operating system. It won't do it like a hardware switch. Okay? But I also have turn off, which is like turning a hardware switch off. ICs give you that feature. Now, I said, well, what about Windows 7? So if I connect to Windows 7, which, by the way, this is the one that crashed, you come over here to Action, Insert Integration Services. Okay? So this will mount the ISO for you and let you run the setup program. That's all you need to do. Okay? Yeah, you really don't like me, no matter what you say. There we go. Now, the big questions you have to answer, well, how many virtual processors do you give a VM? How much RAM do you give them? How many disks? What kind of disks? What about networking? How do you get connected? So in virtual processors, what's happening is Hyper-V is virtualizing the processor. Now, this is different from emulation. When you go inside a virtual machine and compare it in Device Manager to your real machine, what you're going to see is you're going to see a set of synthetic drivers that provide hardware services in the form of drivers and software to Windows or your other guest VM like Linux. However, the processor always is passed through. So for example, on my machine, we have an Intel 2 gigahertz 920 processor. If we go look at my VMs think that's the exact processor they have. If I switch them to a new Core i7 3920, they would think they have that. Okay? So that is virtualized and passed through. Now, VMs always see what are called logical processors. The number of logical processors that you have for code execution inside the VM is calculated through a formula of number of sockets, so number of physical chips, times the number of cores, and then it's times 1 or 2, depending upon whether hyperthreading is turned on. Okay? So on my machine, if you saw the picture earlier, you saw I had 8 little processor cores on my host. So that means I have, in this case, a single socket processor, so one on my laptop, that has 4 cores, so 1 times 4 is 4, and hyperthreading is turned on, so 2 times 4 is 8. So I have 8 logical processors available to Hyper-V. Now, it doesn't mean you're limited to having, say, 2 VMs with 4 virtual processors each. Hyper-V will take care of the resource scheduling. You can do some resource control stuff. But the point is, that is your baseline. And then Microsoft has calculations, particularly for server-based deployments, where they'll tell you, if you want to do this type of deployment, here's the maximum of VMs with this many virtual processors assigned you want to run. So let's say your developer boxes are being put on a server. You would try and figure out, well, how many virtual processors do I want? A developer should have at least 4. I think that's a good number. Maybe 8, right? Woohoo! Okay? Well, you do the calculation. How many are available? What's the workload going to be? Well, we're going to be working hard. Well, maybe we only want to have 4 developers on this server when there's only, say, 8 or 32 logical processors. Now, look at those numbers, though. With the new version of Windows 8 in 2012, 320 logical processor support. That's some serious processing power. They made a big jump. Okay? Now, how do you set this? Well, I showed you earlier, and I'm just going to point out a couple other features in there that are important. Oh, let's do it again. Let's do the limbo. There we go. All right, let's go back to this live AMS that we were creating. Let's go to the processors. All right, so the first thing is number. Okay. Well, in the new world, you can have up to 64. So they just let you type in the number you want. Okay. Obviously, this is dependent on the host. In Jeff's demo on Tuesday, the VM that they were using for that IOPS test had 64 virtual processors. The physical box had 80 logical processors. All right? Now, so you adjust the number of virtual processors, and then there's all this stuff related to resource control. Here's the bottom line. For the average developer, you don't need to do anything. It'll just work. Now, maybe you got too much time on your hands. You're waiting for some other developers not as good as you to finish their code, so you got some time to play around. Sure, go for it. And what you're basically adjusting is the resource management and how, when you exceed the number of available logical processors, how it does scheduling. So you can decide that the domain controller, because it's only answering basic authentication requests and maybe occasional DNS requests, it doesn't have to always be running full speed. So you can drop down its availability, and you can give your SQL Server VM more availability. And if you take a look here on my machine, and you can click this drop down to switch between VMs, if I go to the domain controller, yes, I'll continue, you'll see my domain controller only has 2 virtual processors, but if I go to my SQL Server, I've given it 4. Okay? And so you can control which VMs basically should always be given highest priority as far as processing on the virtual processors versus other VMs. Okay? So background services that don't do a lot, you lower theirs down. But in general for developers, yeah, just leave it the way it is. Yes. 1, 2, 3, 4, 5, 6. There we go. Okay. Now, memory. 2012, Windows 8, you can have a VM with up to a terabyte of RAM. Yeah, that's a dream. Okay. The bottom line is the limit in Hyper-V is not going to stop you. The problem is, this is a big mistake I see people make anytime they create a VM. Well, they always think more is better, so they want to give the VM a lot of RAM. Particularly because you'll look at things like Microsoft's minimum recommended amount, especially for things like SQL Server, TFS, whatever. And so what you've done is you go and you give it gobs of RAM. The problem is, if you're a developer, a lot of the times you're the bottleneck, right? You're the one doing the context switching between threads of execution. So a lot of times all the VMs are mostly sitting idle, right? Unless you're doing something like load testing. Be conservative with your RAM choice. Okay? Use dynamic memory to set the minimum amount of RAM you want the VM to have. You can also put a buffer, which will try and maintain that buffer until it's put under pressure. And you can specify the maximum it can have. Okay? And you can decide a hard maximum, or you can let Hyper-V manage that maximum. It's up to you. Okay? The key thing about dynamic memory is that it doesn't let you overcommit. You can't ever give VMs more RAM than your system has. Okay? And they support not only giving VMs more, but they also will take it away. So they will balloon and shrink the amount of memory that the VM has. And that's really cool, because then you can get more VMs running at a time. Now, once again, we're going to go to a similar location. One of these days. There we go. Right, we go into memory. Now, my SQL Server is not running, so I can change everything here. First of all, startup RAM. Now, this is the other thing. It turns out things like Windows 8 and other operating systems want a minimum to start up, but they'll actually will balloon down to less even if you're not using it. So you'll notice that I can come in, for example, to my Windows 8 VM here, go to its memory setting. Startup is 1536, but notice I say, you can go down as low as 384. Now, I've got this VM running, so I can't change it. So let's cancel. And let's go down here, click on it, and go to the memory tab hit at the bottom. And take a look at that. When it started up, it started with 1.5 gigs of RAM. But it's just been sitting here doing nothing. I haven't even logged in. So Hyper-V said, oh, you're being a pig. Give me some of that memory back. Now it's available to the host operating system for you to do things in Visual Studio or whatever, or even for running other virtual machines. Okay? So that's a really great feature. There we go. Okay, virtual storage. Oh, there we go. Hey. Virtual hard disk. So as I mentioned, a virtual machine needs to have a hard drive. It's represented by what's called a virtual hard disk. Microsoft has two formats now. Everything prior to Windows 8/Server 2012 is in what's called the VHD or virtual hard drive format. It's backwards compatible across things like Virtual PC, as well as Virtual Server and the various flavors of Hyper-V, and it is still supported in Windows 8 2012. However, they're limited to a maximum of 2 terabytes in size for SCSI and 127 gig for IDE. With the new release, they've created what's called the VHDX format, which offers better resiliency. Basically, your server crashes, run out of disk space, whatever. And thus, better security for data and generally better performance. Up to 64 terabytes in size. And this is what you want to pick if you know you don't want to try and move the VM between an older machine. Okay? Now, when you define a virtual hard disk, you specify how big will it appear to the client operating system. Okay? However, you have a choice whether or not you use that much disk space on the host machine. You can either have what's called dynamically expanding virtual hard drives. What that means is you can say, I want it to be 32 gigs in size. But when it starts out, it'll be like 312 KB. And it's only as you put data into it will it grow. Fixed drives, on the other hand, will actually allocate on the hard drive, on the host that you pick, immediately whatever size you specify. For developer VMs, I always start with around 32 gigs because modern versions of Windows will eat 8 to 10 gigs right away. Throw in Visual Studio and a couple other things, I'm good and I got a little buffer. It's very easy to make your virtual hard drives bigger. It's a lot more difficult to make them smaller. Especially if what you want to do, you decide you want to make them, convert them from dynamic to fixed, which you can do. All right? So plan that out. Go with dynamic generally. If you have an SSD, you won't even notice the perf. Now, if you're going with a mechanical hybrid drive and you're trying to get the best performance, you'll get better performance out of a fixed drive, a fixed virtual hard drive. Okay? Now, the other thing is once you create the file, this VHD, you have to connect it to the virtual machine through a controller. Hyper-V supports 2 types of controllers, IDE and SCSI. The big thing to understand is you have to put your boot VHD on the IDE controller. And you can use SCSI controllers for very large hard drives as well as hot add and remove. Okay? Now, there's a feature in the VHD subsystem known as differencing drives, and these are awesome. What this allows you to do is create a child of another drive. And what happens is when you have a child with a parent, all of your write activity goes to the child. Reads are done across both drives. And this provides somewhat like an undo feature. But what it's really cool for is having a base operating system with your base tools, and then you can create different child drives on top of it. You can apply, maybe you want to test out different third-party tools. Maybe you're looking at DevExpress and Telerik, and you want to try them on their own. So you take a Windows 7 VM, then create 2 diff drives pointing to the same one, and use one to install the Telerik tools and one to install the DevExpress. So you try out the Telerik, shut down, switch to the VHD, and go up and forth. You can also do it to test service packs on top of an existing drive. And what happens is you decide that, oh, I don't like what I did, you just throw away the diff drive. Okay? You can also merge them with your parents if you decide that you like what's in that drive. So you have a parent, create a child on top of it, create a grandchild. You can basically create arbitrarily long trees, and you can create trees with branches where they spark off at each other. Now there is a level of indirection there, and there's 2 downsides about this. Number one is there is a perf penalty. The bigger perf penalty comes from the fact that children, when you add them on top, are dynamic by nature. And they will grow larger at some point, if used heavily, than their parent. Okay? So they're better used not as a day-to-day activity, but something for trying things out. In addition, they're definitely not recommended for production environments. Okay, VHDs. There we go. All right. So once again, if we look at live AMS, go to Settings, go to IDE Controller. I would click Add, Virtual Hard Disk, New, and I get a wizard that lets me choose what I want to do. First of all, Format. They default to VHDX. Consider the other for backwards compatibility. What kind? Do you want to be fixed, dynamic, or differencing? Finally, pick the file type. Next. How big do you want it to be? And then hit next and you're good to go. There's also something on there called pass-through. Generally for developers, not worth the complexity and effort. But basically lets you use a physical drive and it's presented to the VM as a virtual drive. This is one way if you're really trying to get the best performance you can also do. But you basically lose that physical drive to Hyper-V. Okay, networking, very flexible, and once again, if you're really into this, go look at some of the server features because you can create virtual switches, you can get plugins from Cisco, Big IP, all sorts of crazy stuff. There's basically 3 network types: external, internal, and private. An external network means the virtual machine is on the network like any other machine. It's going to try and get an IP address from your DHCP service. It's going to look for DNS services on the network like any real machine. Internal means it's visible to the host it's running on and other virtual machines, but not outside. And private is for VMs only talking to themselves. Really straightforward. Windows 8 brings official Wi-Fi support. Now, when you go to pick a network adapter, there's 2 types. There's regular network adapters, or what are called synthetic, and legacy network adapters. Bottom line, you always want to use the network adapter if you have an operating system that is supported and has integration components, because it's going to give you much faster. The performance of the internal network card will be as fast as the physical card. So if you have gigabit, you'll get gigabit inside the VM. If you have 10 gig, you get 10 gig on the outside. Right? But if you only have 100, doesn't matter what the VM inside said, it's going to be limited to whatever the host is. Legacy you use for doing network installs primarily, so Pixie boot, or if you're trying to run an operating system, God forbid like NT4, that doesn't have integration components. All right? That's about it. Setting up the settings. Well, there's 2 places you need to go for this. Okay. First is on the Hyper-V console, you go to the Virtual Switch Manager. And notice there's an option here to create them. You pick which one you want. So you say, for example, external. Then you pick the physical card to use if you have more than one. The only thing that's interesting here that I haven't talked about is this. Do you want the management operating system to share? Most of developer machines typically have one processor. Some of the newer desktops come with two. If you have two, great. Give one to Hyper-V and one to yourself so you create two virtual switches. Laptops, you're going to want to do this because you're going to want to be able to have your physical network card be able to get to the network as well as the VM. And you can see we have the other two options here. If your network card supports it, you can do things like VLAN tagging, which basically allows you to isolate network traffic between one or more VMs. And then you can see internal Wi-Fi. Wi-Fi is just uses a different NIC connection, and you're good to go. Now, first you have to set up the switches, one or more of them, and then when you go to the VM, you pick one of those virtual switches from the list. If you've enabled things like VLAN tag, if you enabled VLAN tagging on the switch, you can control that in here. And there's also new features related to bandwidth management. You can also expand here if you've got specialized network cards, which is unusual for most developers. But you can get things like IPsec offloading, which means on secure networks you'll get better performance. TCP IP chimney support. That stuff requires generally server-grade cards, so you generally won't have to mess with any of those things that I just kind of said. They're there. Okay? All right. All right. Getting connected. Now, here's the one thing you run into when you first install the operating system. It's probably not going to show up on the network, which means you won't be able to use RDP into it. That's where VM Connect comes in. VM Connect is the window that pops up when you right-click on a VM and say Connect. It's a specialized RDP client. What makes it special is that it connects directly to your host machine through what's called the VM bus. It's basically talking to the video driver inside the virtual machine through the Hyper-V direct hypervisor. Once you can get connected, you generally want to then enable some form of remote access, whether it's RDP, VNC, whatever, because you'll generally get better features. Now, VM Connect is good because from that toolbar at the top, you can start, stop. You can connect when there's no network connectivity. The problem is it has limited network resolutions as well as limited clipboard support. You can basically just get text to type in, no rich data exchange. So I'm almost always going to be using RDP on my end. But wait, there's more. If you buy now, you can do things like boot to VHD. So one thing that's great about virtualization is I'm able to run, an entire virtual domain you've seen here. I'm running a bunch of VMs. I got gobs of RAM. I have fast hard drives. You're going back to work and saying, well, that was cool, but my hardware sucks. You can still get a benefit that's related to virtualization, but isn't specifically. It's device virtualization. It's boot to VHD. Here's what you're going to do. You're going to create a VHD file on your host, but you're not going to run Hyper-V. What you're going to do is you're going to point the bootloader on your machine to the VHD. You're going to make it appear as if it's a hard drive to your physical bootloader here. And when you boot up your machine, you'll pick it from the start list. And what will happen is all of your activity related to disk I/O will be contained inside the VHD. But unlike a virtual machine, you're going to see all the real hardware you have. You will see your real video card. You will see your USB ports. Anything that Windows sees, you'll see, unlike a virtual machine. This gives you a lot of the benefits because now I can back up just that VHD. I can even do things like diff drives and undo support. Okay? And this is good for when you have software or hardware technology that won't work in a VM. Okay? This is really good stuff. And if we look at my machine, one second, there's a couple of tools. How do you set it up? Well, basically there's a tool called BCD Edit. This boots the boot configuration store editor and lets you create new boot entries. When you create a boot entry, you give it a name, you give it a unique identity, which is a GUID, and you point it to the drive, either a physical drive, which normally we don't ever deal with because it's done automatically, or you point it to a VHD file. You can also use BCD boot as a quick and dirty way to get an existing VHD running. Diskpart will let you create them from the command line. It also works inside WinPE. You can also do it through the computer management console. And then there's a system configuration tool which will show you what you have available to do your for your different boot configurations. So I want to show you what's on my machine really quick. Okay, so first I'm going to run system configuration, which is available on Windows 7 and is deciding it doesn't want to show up for me, so we'll do msconfig. And you go to the boot tab and you'll see I have 4 different operating systems available here. Windows 8, Windows Server, Windows 7, I've called something Apollo. Now, you'll notice I have one marked as the default, and that's the one that will start up if I don't pick anything. Otherwise, I can pick any one of these operating systems. And right now, you'll see I'm running Windows 8. If I go to Windows Explorer, this is what's twisted. This is a VHD. W510B is my C drive. On the other hand, I've got this D drive, which is my Ultra Bay, and then I got one here called Windows 7 OS F. If I go inside there and open up Boot to VHD, you'll see I've got this really big VHD right there. Okay? And so that's what I'm running all my stuff in here. Now, BCD commands, how do you do this? Well, generally you copy one of your existing entries. And you can do that by doing copy default or current. When you do it, you give it a name. You can remove them with delete. And when you want to actually change the description, use the set command. And finally, here's the big 2. Device and OS device, you point them at the file you want to use. Okay? Notice this little trick here. I learned this from a buddy of mine named Ronald Beekler. So I give him the tip. Normally the documentation you'll see here will have you put a physical drive letter like a C drive or D drive. The problem is with multiple drives, sometimes Windows will switch the drive letters. If you do locate and you don't have that same VHD file name at that same path on multiple drives, it'll figure it out automatically for you. Okay? And I'll post this up on my blog for you guys and talk about that. You can also change the sort order with BCD edit. So it's really not that hard. I'll point you to some articles that show you how to do it. But it's a great lifestyle to lead if you can't run Hyper-V completely and have the performance that you really want for virtualization. All right. One of the big things missing for people moving from things like Virtual PC to Hyper-V is undo support. There's no option that says when I shut down just to undo. Well, Hyper-V doesn't do it exactly because they have something that's more powerful called snapshots. Snapshots allow you to grab point-in-time copies of both the configuration of the virtual machine, how much RAM, processors, etc., as well as the current state on the virtual hard drives. You can create snapshots when the VM is shut down, generally the best safe way to do it, but you can even do it while it's running. And at any time, you can then take that snapshot and you can point back to it and move the VM back in time or move it forward in time, depending on what you were doing. This is really great except for things that are date sensitive like domain controllers. Okay? If you're going to do it with domains like I've got here, I've got this entire virtual domain, just make sure you roll back and roll forward everything together. Otherwise, various Active Directory stuff can get out of sync and it gets ticked off. Okay? Now, snapshots. Really good stuff here. So you'll note I've got a couple different VMs here. Now I showed you this already. I have this VM here, that blue screen. And you notice what I did here. When I get a VM the way I want it and I'm going to start playing with it, I take a snapshot and that creates this root you see here. I then rename it to undo. And then anytime I want to just start over, I right click on that and say apply. Now when you go to apply a snapshot, it'll ask you, do you want to make a copy? No, I'm okay, just do it. Or you can actually create a new one. So it'll create one to back it up. At any point in time, you can delete individual snapshots. Right click and delete. And you can right click and select snapshot at any time, running or not, to create one. Okay? Really powerful stuff. You do not like me today. There we go. Okay, this is a big one. If you've ever done this with Hyper-V, you understand. You have all these snapshots, and you decide, I want to get rid of the VM. So you go to delete it. And next thing you know, it takes half a day to delete. If you have a bunch of snapshots, Hyper-V, because they think, well, maybe you want this data, they never want to lose your data. They want you to be very explicit. When you go to delete a VM with snapshots, they will merge all of the snapshots into the main VHD. This can take hours. So the trick is simple. Either delete all the snapshots, or what I do, I go to the root snapshot. For me, it's always called undo. But you go to that top one, the very top of the tree. You apply, then delete the entire tree of snapshots. You right-click delete subtree. It deletes them all. Then when you delete, it'll show merging, and what will happen is it'll just merge that root. But you've already applied the root, so there's nothing to apply, and it deletes right away. And then you go out and delete the physical, the VHD files. But that's what you got to be aware of. Trust me, do it the wrong way first, and you'll be begging for the slide and trying to remember what happened. Okay? Other tips? Boot to VHD. You should use fixed VHDs unless you're really compulsive. Because what happens is, let's say you have a drive that's 100 gig, an SSD. But you're like, well, I want to have a couple boot to VHDs. I don't have enough room to keep 2 full-size ones on my hard drive. So I'll make them, say 15 gig. So at runtime, it's going to expand to 15 gig. But when you're not using it, it's only 10. And you do that a few times, and you forget, and you download some movies on iTunes, and you're doing all this stuff. And then you go to boot into one of your VMs, and guess what happens? This is your boot to VHDs. It blue screens because it can't expand the drive. Okay? So use fixed VHDs to make sure you never lose the disk space, or you got to be really compulsive and keep track of your disk space. Okay? Watch out for drives greater than 2 terabytes prior to Windows 8 2012. You can't export and you can't run VHDs off of those very large drives. It has to do the way with the hard drive vendors do their sector translation so that Windows can use the data. With 2008 Windows 8, you can put your VMs on 4 terabyte drives and you can export to them and import from. But you can't on 2008 R2 and earlier. Thumb drive.vhd, here's the tip. With SCSI hard drives, you can hot add them anytime you want. Well, if you have a VM that can't get to the network and you need to be able to exchange data, all you do is create a little VHD, hot add it, and there you go. It's like a thumb drive. Make it as big or small as you want. Okay? Optimize your dynamic VHDs. Over time, they will grow as you add and delete stuff. So there's a compact tool inside the wizard. You just click the drive, say edit, and there's a compact option. The problem is it only does tail cleanup. If you grew the drive to, say, 32 gigs and deleted 16 gig, well, it's probably in more of the middle of the drive. So you need to zero out that space first with something like sdelete, then compact. Okay? Building gets better. Get yourself MSD and TechNet. Watch out for product activation. Only activate if you're going to keep the VM past the evaluation period. You can get 90 days out of Windows client machines, and you can get 240 days out of Windows Server VMs. Okay? Even Microsoft internally says to test teams, don't activate unless you need to. Okay? Don't burn your product keys. Sysprep is your friend. Definitely take a look. It's not scary. The other thing is, getting your machines, they have to be patched, folks. They're real machines. They need antivirus. I got a tip from an attendee here, Richard Knight. I was eavesdropping on him in the bar the other night, which makes conferences great. And he told me about a tool called WSUS Offline Update. It will basically pull a bunch of updates off the Microsoft Update server and create an ISO for you. You then can go to a VM that doesn't have network access and get it patched really easily, and it'll apply all the updates. So check that out. And like I said, you can search on it with your favorite search engine, or I'll have a link on my blog. I'm going to keep going because I've got one last thing to show you, and I'm almost out of time. You can automate Hyper-V. If you're hardcore, you can do it through WMI, so COM-based languages. You can use C# through system.management. But in 2008 R2, in 2012 and Windows 8, we now have PowerShell commandlet in the box. This means you can do really cool stuff. So this is my last big hurrah here before this timer ticks down. Let's try again. All right. So I've got 2 scripts I'm going to show you. The first one I'm not going to run, but it's basically a way to export. So if we go over here to Hyper-V, you'll see I've got these VMs numbered 1 through 6. This represents a test domain where I'm able to do things with SQL Server, SharePoint, SCOM all at once. I can do all sorts of simulations. The problem is when I get to a point, sometimes I want to make a backup, right? Because I'm a little paranoid, especially with SSDs, right? Well, the problem is right-clicking, selecting export, which basically is how you back up. It's a pain in the tushy. So, got a little script here. And I can't take credit. This was written by a guy at Microsoft, but, you know, flattery is the best form of impression. And if you come over here, you'll see it's a little script that comes in and says, okay, I'm going to get a hold of this particular VM. I'm going to call export, and I'm going to run it. And I'm going to run it, and I'll get the results. Just a really simple script that's using some of these built-in commandlets. And then I just have a batch file that I call that lets me call it multiple times. I'm not a PowerShell expert, so I'm sure I could write another PowerShell script to do this better. But I just come over here and tell it to run this and export particular VMs. So you see I have a batch here where I can export all 6 of these so I can walk away, go have some coffee, maybe have a cocktail and come back and go back to work. Okay? But here's another cool thing you can do. Let's say you're a developer, you're in Visual Studio. And let's say you want to use this VM here that's Windows 7 to do some testing. The problem is you have to get it all set up, etc. Well, wouldn't it be great if it wasn't running? Let's see. It's not running, is it? Yes, it is. Let's shut you down. Okay, and you go to Visual Studio. And I'm getting the red light of death, so they're going to yell at me and get cranky. But we've got a break. And we come over here and open up a piece of code. The code is irrelevant. It's a WPF with a giant button. Okay? Wouldn't it be great if I could deploy it into my VM so I could test it in that environment where I've got a bunch of configurations set up already? Wouldn't it be great if I could just do it through building? So how about this? I'm going to bring Visual Studio down here, watch the VM, watch the VM. There we go, started. Oh, this worked perfectly earlier. Ah, the failure of death at the last second. What are you doing? Well, let me show you what it's doing, and then I'll figure out why it's broken. But basically, I'm just using pre- and post-build events. And it's running a command file that calls a PowerShell script that's starting the VM and waiting for it. Oh, yep, so it didn't start. Well, in either case, apply the snapshot. Actually, it's this one I want. Let me just try one more time. Well, that's why you might want to do a little better error handling. The bottom line is it starts the VM, it copies the code into the VM, and connects with an RDP session. So you can automate those mundane tasks. You don't have to sit there. And it's really straightforward. Like I said, I ran it 30 times before I came up here. You'll notice my last undue time was a couple hours ago. But in either case, I'm out of time, and I won't debug it. Darn it. Really? There we go. You're going to just finally switch for me. No, we won't. We'll make you stare at the humiliation and shame of the failed demo. No! Switch! Well, there really is a summary slide that tells you, hey, love you, do your evals, but maybe you don't want to do that. Goodbye. There we go. Hey. Goodbye. Do your evals. 4 is best. Yeah, I'll look for that. Virtualization is great. Long live prosperous. Email address, Twitter. Abuse me later. Thank you.